Hello, I'm Armat Touche, and I'm the team lead. For this project, we work on Teach Safely for the Summer/Fall 2022 Computer Science Capstone cycle here at Portland State University. The sponsor for our project was Micaiah Mock, who was the architect for the web application system. Him and his team were the previous contributors to this project, and we're just coming in behind and providing another iteration of development. So, a little description about Teach Safely. Teach Safely, again, is a website, and it is a learning and certification management system designed initially for woodshop teachers in order to solve the lack of continuity managing certifications and also help streamline education in regard to, for instance, learning how to be safe when dealing with a bandsaw, for instance. Lastly, once this system is implemented for the target school, future goals include other schools and then also post high school industries. Some examples: electricians, plumbers, anything that needs any type of certification and education that goes into that. Before we dive into specifics, I first like to define the scope of our capstone project. First, as I mentioned previously, we are a continuing project. So with that comes another iteration of development, which is what we provided. So during our mid-project time period, once we got our signed code base, we went into the GitHub repo hosted on github.com and read the documentation. Concurrently, as we were looking at the code base, I was also in the requirement gathering phase with my sponsor. One suggestion that he made was to examine the repo's documentation, more specifically the backlog, and use that as a template, which is what my team used. And also, as we were setting up the application, we also came up with some suggestions and made promises at our mid-project presentation, these deliverables. In this slide, as you can see, this is the target audience. First being future software developers. For this point, we really thought about how would future teams be able to develop and implement features for this application. For the second point, we also considered the high school shop teachers. And then lastly, we also considered the website admins. So this could be also non-technical or technical workers. The big stuff that we did listed here, these were the major points or deliverables that we delivered. First one being quality assurance for the user interface and user experience, QAing the backend section of this web application. We also set up a continuous integration and continuous deployment pipeline. And then lastly, we added some features to the teacher portal.
Hello, everyone. My name is Daniel Becerra. I'm a computer science senior at Portland State. I have interest in pursuing higher education in human-computer interaction. Some things about me are that I love to hike and learning about tech, and I've recently been enjoying this World Cup. So I want to talk a little bit about this project and how we were able to tackle it a bit. My role was a front-end developer, but I also provided quality assurance for the user's interface and interactions. Focusing on the front end, I was able to get a better understanding of this website by first understanding its interface. Vue is a JavaScript framework which is used for web development projects. And in this project, it allowed us to interact with styling as well as different front end services. But it also worked very well for this project in incorporating web services for the backend like AWS. As we mentioned previously, we received a working version of this website, which we continued off from. Working with the original creator, we were able to get a better understanding of what this website's purpose was and how we could continue it. We provided additional documentation for future teams, maintenance, as well as some additional functionality. We were able to test the website's front end services through automated testing using a tool known as Cypress. So, Cypress is an automated testing tool suite which provides end to end testing for web services. In our case, it was more so focused on the front end. So, working on this project, we started off by splitting this workload into two terms where Since it was a continuing project, we worked first in getting a better understanding and a better feel of this website in general. For the first term, we looked to document any findings related to the front end, looking to look for any user functionality, any bugs that might be related to this. And once we were able to do this and get a better understanding and become more familiar with this website, were we able to transition into the second term where we actually started doing end-to-end testing and providing some additional functionality. So in the second term, we looked to provide additional code coverage, as we mentioned. Specifically, we provided testing for teachers to access and log into their accounts. Once they were in their accounts, we also tested that they were allowed to create new classes, which they could then add lessons to. All in all, this was a great learning experience. Although difficult, it was great for learning web development and becoming more aware of automated testing and what it can do for projects like this.
Hi, I'm Martin. So we use Cypress for testing the backend as well, but the implementation is very different because Lambda functions can't be directly interacted with. Lambda functions are executed remotely on AWS servers or locally with the serverless offline plugin. We decided to prioritize E2E tests to validate that all the components talk to each other properly and return the expected output. These tests basically take a function input, post to the Amazon API gateway URL. That invokes a Lambda function, which usually is doing something involving DynamoDB. Then the Lambda returns its output through the HTTP response. Because they're called via an HTTP endpoint, you can invoke the functions offline for local testing, or invoke them on the AWS servers by simply changing the API URL. We added end-to-end tests for all of our new Lambda functions, as well as about half of the existing ones.
Hi there, my name is Miles Johnson, and I took on a software engineer role for Software Engineering Capstone's Summer/Fall 2022. I'm going to talk about the team's work implementing a CI/CD pipeline for the Teach Safely website. CI/CD stands for Continuous Integration and Development and is a crucial part of any modern software development operation. It allows for automatic validation, seamless updates, and feature additions to an existing product without jeopardizing availability. The previous team to work on Teach Safely was primarily tasked with rapid prototyping, and the site was offline, so CI/CD was not a priority. Looking at the architecture diagram, we can see that deployment of the website requires pushing front-end code to an S3 bucket and uploading Lambda functions for communication between end users and the backend. Both of these responsibilities require the handling of credentials as well. An engineer was able to deploy the site by manually running a large script that relied heavily on dependencies residing in subdirectories, sometimes with versions that differed from other project components, so it was easy to break. Since Teach Safely uses GitHub for version control, our team used GitHub Actions to implement a CI/CD pipeline. This screenshot shows the result of a job that is executed automatically when a pull request is approved. It spins up a virtual machine, builds the necessary environment to run the deploy script, gathers credentials from GitHub secrets, then runs the script. This workflow is currently set up to deploy to an experimental stage and does not touch production. As an added bonus, we threw StackHawk's HawkScan utility into the GitHub Actions workflow. This service is recommended by OWASP and builds, then scans the application for known vulnerabilities and exploits. Results are then output to a web platform that the project owner has access to.
Hi, I'm Brooke, and I'll be talking about the features we added to support Teach Safely teachers in their classes. The team was able to add two useful, teacher-centric features: teacher lesson locking and the manual administration of quizzes to students through printable PDFs. First, we'll look at the lesson locking feature. It allows teachers to lock lessons that have been added to their class. The students on the class page can still see those locked lessons, but they are grayed out and inaccessible until the teacher unlocks them. Here's a short demonstration of their functionality. This is a view of the teacher page for our woodworking example class. You can see that bandsaw safety and nail gun safety are locked, but hammer and nails is unlocked. This is the student view for the same class. As you can see, the locked classes are grayed out and appear at the end of the list. Clicking on them does nothing. Students can see them, but clicking is disabled. But if the teacher updates the lock status of the class using the slider, and then the student refreshes, you can see that it updates the view, and you can get to nailgun safety now.
Another major feature our team implemented is the ability for a teacher to manually administer quizzes. The idea is that a teacher would download a previously existing quiz related to a given lesson, then present physical copies to students in person. The implementation required writing a new Lambda function, using an open source package to translate data into PDF format, and building new UI elements.
Hi, my name is Kit, and while it may not be surprising that documentation and an ergonomic development process makes work faster, it may be surprising that establishing those things can be a big project sometimes. We quickly realized when starting this project that there was no way to fully run the project offline, and we realized that working parallel would be problematic without that. So we endeavored to set that up, and it proved to be quite a challenge. It turns out that modern web stacks are not trivial to run on just one computer, and we had to integrate multiple plugins and write custom code just for the development environment.
Hi, my name is Clara Stickney. Let's talk about the architecture of this project. The main components of the architecture supporting Teach Safely are Amazon Web Services for the backend and Vue.js for the front end. Here you can see a very high-level view of the many components that make this project tick, but let's drill down further into the primary pieces. For the backend, there are 4 primary services in use: DynamoDB, S3, Lambda, and API Gateway. DynamoDB and S3 store resources. DynamoDB is a NoSQL database, storing data such as lists of classes, lessons, and teachers. S3, however, is used for larger unstructured data. For our purposes, it stores lesson and quiz content in S3 buckets. AWS Lambda is a serverless, event-driven compute service that runs code at the capacity we need as we need it. It is responsible for the functionality of Teach Safely via Lambda functions. In conjunction with Lambda, API Gateway is used to create HTTP endpoints to trigger these Lambda functions. The serverless framework is used to manage all 4 of these backend services. It deploys Lambda functions and API endpoints, as well as the needed resources stored by DynamoDB and S3. As mentioned, the front end uses Vue.js, a JavaScript framework used to build user interfaces. Vue allows the users to correctly interact with their respective interfaces. S3 is relevant here as well, as it hosts static content for the website. Altogether, these backend and front-end services communicate with each other to provide a seamless experience to the users, admins, teachers, and students. First, the admin portal allows an administrator to create and manage lessons. Then, from the teacher portal, teachers can access these lessons, create and manage classes, and manage student records. Finally, the student portal enables students to interact with their classes, such as review a lesson or take a quiz. The result of these actions will in turn update their student records.
Hello again. I'll be talking a little bit about our approach to developing Teach Safely. Some key things that we had to consider was training. At the beginning of the project, as mentioned before, we scrubbed through the repo, examining the source code, setting up the dev environment, and at the beginning we really focused on this bullet point. On the next bullet point, teacher component, this entailed reading prior documentation, user scenarios, and other documentations present in the repo. And then lastly, When planning the CI/CD pipeline, with this we did a lot of meetings with our sponsor, asking questions that we prepared ahead of time after examining, for instance, the deploy.js script, which was a critical component in deploying this application across the several services mentioned before. As you see here, these are responsibilities. And then in this slide, unexpected events that occurred are as listed. We had to spend a bunch of time learning a new tech stack, knowing which database was used in the offline and then also in the production environment. And then, as mentioned before, getting stuff working locally was harder than we thought. Going forth, I think future software engineers should be considered in future development, and then also increasing the quality assurance across the whole code base. And then lastly, I think the backlog is again still a good template and should be dynamic, meaning it should grow or shrink based off the needs of the customer. All in all, lessons learned for me. I learned a lot by leading a development team, received a better understanding of AWS, and QA is not as glamorous as rapid prototyping.
Martin here. I learned a ton about the AWS cloud ecosystem. I got some great experience working on interdependent tasks, very different from the typical internship experience. And every time I asked for help, it saved me so much trouble, and vice versa.
Hello. So some of the lessons that I learned came in the form of roadblocks and issues that I had during my time working on this project. They were mainly unanticipated and definitely lessons that were helpful but difficult at the time.
We didn't really do code review, and I think part of the reason for that is we didn't really talk about it ahead of time. And when it actually came time to merge changes, nitpicking our teammates' hard work really just didn't feel like how we wanted to spend our precious Capstone time. But I think code review could have helped us sync up and get familiar with each other's work. We were initially planned for pair programming, but that can be really hard on busy college schedules. It would also help us squish bugs and catch misunderstandings before they have a chance to happen. So were I to do it again, I think it would be nice to establish as a team how we want to process PRs before we get to that point. I also learned that, at least for me, enjoying being around and working with my teammates mattered a lot more to me than how I felt about the work. I liked my Capstone teammates a bunch this term, and so thanks to them, I still felt generally good about things, even when it felt like we're behind and things were not working the way we wanted them to.
The biggest takeaways from this experience for me are that maintaining and working on a live product without breaking anything is a major challenge, communication with teammates is crucial for meeting milestones, and that there is simply no easy way to dive into an existing code base and become fluent quickly.
Hi, Clara here again. Three things I learned throughout this project are that teamwork makes the dream work, roadblocks stack up very quickly, and communication is key.
I learned a ton working on this capstone. I went from only knowing older front end technologies to writing components for a single page application in Vue.js. I'd never used an API before, but now I fully understand the process of creating and receiving both requests and responses. And I helped set up the local instance of the database for the team to work with. I also learned that it's important to be careful when deciding on dev environment changes, as there may be hidden difficulties that arise during the transition. I think future teams that I'm a part of may benefit from rolling the dev environment changes into their own feature so the rest of the team can work without roadblocks in the meantime.
Here's a little feedback from our sponsor. Again, my name is Armat Touche. I'm the team lead for this Capstone project. Thank you for listening, and also, good job, team.